Okay, for assignment 4, you're going to work in the k-means clustering algorithm. You might want to review the videos of that algorithm that we had from Stanford. But I'll go over it again here to refresh your memory too. So I have some code in Java that implements this clustering algorithm for a given number of clusters k. So we'll try 2 clusters, 3 clusters, and 4 clusters and try to cluster the data and see how this algorithm clusters the data if we just have 2 clusters or if we have 4 clusters. And in each case, we're going to have to move the cluster center to the average of all the values in that, all the x and y values. This describes it a little bit, but let's jump to the code and see this a little bit more. So here's the k-means clustering algorithm. It uses a data point object similar to our k nearest neighbor. It's kind of confusing because both these use k's because you can use any number of nearest neighbors or clusters. But remember, the nearest neighbor is supervised. We know the data and how it's assigned already. This k-means isn't necessarily supervised, although we'll be looking at kind of supervised data to give it some meaning here. So here's our data points. We have a set of 15 tree plants, and some of them arbitrary are labeled white pine trees, some of our maple trees, some of our bushes, and some of our shrubs. But we're not going to let the algorithm know about these labels. We're going to see if it can figure out which are which and cluster these together in different ways. Now, one way to see this is to look at it graphically. Here's the data displayed. Here's our data here. And so we're looking at the height and circumference of these trees. And white pines are really tall and broad, so those are up here. These are our maple trees. We're just calling these bushes, and here we're calling these little things shrubs. So these, and you can kind of see we're, they are somewhat clustered. This is the bushes and the shrubs are kind of grouped together here, but you can kind of see clusters. So we're not gonna tell the algorithm about these colorings or these clusters. We're gonna see if it can find these clusters by itself. Okay, so in algorithm, we've got the data there. We've got two arrays, one of all these data points, and that's called our data array. And we have another array of clusters, and that'll keep track of our clusters. So like if we run this with 3 clusters, we'll keep track of 3 cluster centers, and then what data points go around are connected with those cluster centers. So that's the clusters array is those center points. We initialize some stuff. We have a method in here to find the nearest mean. So it goes through all the data and looks. So it'll look at first. It'll randomly set up these random locations for these clusters, and it'll go every data point and find out which of these 3 clusters are closest to this, every one. So like this one, it'll find this cluster center point is closer to this, and this one is close to this. Some of them are a little harder to see. This is actually closer to here than here. So algorithm goes through and does that already. Um, Now you have to work on this update clusters method, and that is going to move the clusters and see how it works and run it. So let's look at how that might work. So here I've run this and it asks how many clusters do you want to use, and I said 3. And so it picks 3 random clusters to start, and I've graphed those out here. The first cluster is 28 and 4, 53 and 21. So it has those. Now it's going to it figures out, which data points are close to each cluster and assigns them. And then we're going to go through and calculate the average of each cluster. So this first cluster, the cluster center is at 28, 4. That's this one. And it has these 2 data points are all in this cluster. This cluster has these 3 data points, and this cluster only has these 2 data points. So here's a printout of all those data points in each cluster. And now what it's going to do, what your update method has to do is average out, move this cluster to this new location. So if like for this cluster, it'll add up 35, 32, add up all the x's and divide 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If there's 10 of them, divide by 10. Here it's going to add up all these 3 x's and divide by 3. Here it's going to add up these 2 x's, 29, 25, divide by 2. So we'll get 27 there. I can actually do that one in my head. And again, it'll average these out. So then it calculates new spots for these clusters. So rather than here, it'll calculate new locations. So the first cluster is that when we average out all these numbers, that is going to move to 11.4 and 6. So I'm going to change, well, let's just do that. So 11.4 and 6. So the new cluster, this new one here, is going to move to 11 and 6. I'm just going to approximate. So it's going to put it right here, which is the average of all these locations. The next cluster goes to 64 and 24. So this one is going to jump up. Again, it's average of these to 64 and 24. And it kind of puts it in that location. And then the last cluster, again, there were just 2 values here, 29 and 25 and 19, so it'll just average those 2 values out, and they'll go to 27 and then 20.5. 27 and 20.5. And so it put the cluster, again, right between these two, because those are the only two. These data points were in this cluster. These are only, so it put it right in between the average of those. Okay, so now these are our new clusters, and then the algorithm goes in and figures out what's in these clusters again. And so now you can see that all these will be in this cluster, all these will be in this cluster, all these will be in this cluster, and then we'll recalculate the averages. So we go through this update cluster again each time, updating these with the numbers. So again, now this isn't working. This is the non-working version, and all it's doing is saying calculating a new location. The cluster is now at where the cluster is at is cluster sub m. You're passed in a parameter m because this is called 3 times, one for each cluster. And in this case, since I put in 3, it does it 3 times. So m is the cluster number. So cluster m.x and cluster m.y is the current cluster center, and you're going to have to change that. You're going to have to set cluster m.x to the average. And here's all the data points. It loops through all the data points here and figures out if the data points in our cluster, each data point's marked with the current cluster it's closest to. And then right now it's just printing out the clusters, print out data sub d.x, data sub d.y. My loop variable is d, so it's just looping through all those data points and printing them out. And so you're going to have to, rather than just print these all out, you're going to have to calculate the average. So that's, add up all the x values and divide by the number, the count of the x values, add up all the y values and divide by the count of y values, and store this new cluster, store that in cluster mx and cluster sub m.y. Tried to describe that more here so you can read through this and see if it makes sense to you also. But let's just go through it by hand. So again, we've got these new cluster locations here. And so I've got these cluster values, and I'm going to add these all up and add up all the x's, and there's 1, 2, 3, 4, 5, 6, 7, 8 of them, divide by 8. Add up all the y's and divide by 8. So again, these are all the ones marked as cluster 0 with type if the data d, so that's my loop variable, if the current data plant or whatever, if its type is m, that's my cluster number, then it's in this cluster. And again, I'm going to go through here and calculate all of these, the average of these 3 values, and we'll see those move. So the final clusters are at, the first ones at, let's see, 5.8 and 4.7, 5.8 and 4.7, so it moves it right in the middle there. And then 6.4 and 24, 6.4 and 20, that actually is already there. And then the last one's at 30 and 17, 30 and 17. and moves it. So these are our final three clusters and how it works. And so it actually, in this case, did a pretty good job. It clustered all the bushes and shrubs together, clustered all the white pines together, and clustered all the maple trees together without knowing which ones were shrubs, which ones are white pines, and which ones are maple trees. It does that. Now, it won't always work perfectly depending on what random clusters you get. It will do different things. So if I were to run this again with three clusters, I might get a different set up the different random clusters to start, and then at the end it still it put one maple tree in with the bushes and the shrubs. Sometimes it does that. It doesn't always, there's no predefined perfect clusters for this, so sometimes it'll, depending on what random clusters it gets. And so that's why you want to run it with 2, 3, and 4 clusters to see how it works. um, with 2 clusters, it often clusters all the shrubs and all the trees together. With 3 clusters, again, it often does these 3 clusters, but not always. And in 4 clusters, sometimes it'll get everything right and cluster the shrubs and the bushes, the white pines, and the maple trees all together, but not always. Depending on, we don't have that much data, so it isn't perfect. So, okay, try that out. Again, you'll be working just in this area, and read through the comments and post questions in the discussion area if you have any.